In this example, we're going to look at silver chloride, and we're going to try to calculate the concentration from the KSP value. So, for silver chloride, it says silver chloride is dissolved in water. First thing we should know is silver chloride, when dissolved in water, dissociates into silver ions and chloride ions. These are both aqueous, with the silver chloride being solid. This equation here is reversible because the solid can break up into the silver and the chloride, and the silver and the chloride can combine back together to make the silver chloride. This here is called a solubility product, and the KSP for this value is equal to the products, which are silver, times the chloride's concentration. And since this is a solid silver chloride here, you do not put anything on the bottom, or you can put 1 on the bottom. This gives us the KSP relationship between silver and chloride. The next thing we need to do is plug in what we know, which is the KSP. KSP for this reaction equals the concentration of the silver times the concentration of the chloride. Now, when we look at the silver chloride breaks up into 1 mole of silver and 1 mole of chlorine. It's a 1-to-1 ratio. So if Ag, silver, is X, that means chlorine's concentration has to be the same, because the silver chloride breaks up into a 1-to-1 relationship. This means that 1.77 times 10 to the negative 10th equals x squared. To find out what x is, we take the square root of 1.77 times 10 to the negative 10th. So 1.77 EE negative 10, and then square root of that. In scientific notation, this gives us a value of 1.33 times 10 to the negative 5th molarity for the concentration of the silver ions. It also is the concentration of the chloride ions. Now let's look at example number 2. In example number 2, we're looking to calculate KSP from the concentration. So in this particular problem, we're working with the concentration of silver ions in a saturated solution of silver bromide at equilibrium. So we know the silver bromide is at equilibrium, and this is a solution. So we know that Ag and Br had to be added together, a solid, placed into this solution at equilibrium to make our silver ions and our bromide ions. Our KSP equation is going to be the silver ion concentration times the bromide ion concentration, because silver bromide is a solid. For the solubility product, all we have to do is then plug in the value for our silver, which happens to be 7.1 times 10 to the negative 7th molarity for the silver. Once again, there is a 1-to-1 relationship, which means the bromine is going to have the same concentration as the silver, and when you multiply these two together, or square the value of the concentration, you get a calculated value of 5.04 times 10 to the negative 13th, and that is for the KSP for this reaction. In part B, it asks how many grams of silver bromide must be dissolved to make 1 liter of a saturated solution. So for this, we're trying to determine how many grams are needed to make a saturated, just a saturated solution. So the concentration of a saturated solution would be 7.1 times 10 to the negative 7th molarity, Each mole of silver ions in solution means that 1 mole of silver bromide was dissolved. Therefore, 7.1 times 10 to the negative 7th moles of silver bromide was dissolved to give the same concentration of the silver. So that means this is the concentration of the silver bromide. Then what we can do is we know this is equal to 7.1 times 10 to the negative 7th molarity is moles per liter. And in order to convert this into grams, we know we're using 1 liter. We multiply that by 1 liter, that gives us 7.1 times 10 to the negative 7th moles. That's how many moles of silver bromide we need. Okay. Then all we have to do is convert the moles into grams using our molar mass. So if we had 1 mole of silver bromide, we add together the molar mass of the silver plus the bromine, which equals 187.8 grams. And then we can cross multiply to find out our value for x. So x in this case equals 187.8 times 7.1 e negative 7. And that gives us a calculated value for x equal to 1.33 times 10 to the negative 4th grams. So this tells us that we only have to add 1.33 times 10 to the negative 4th grams to make a saturated solution of silver bromide. If we added any more grams, okay, there would be just more solid that would appear at the bottom of this solution. Here in example number 3, we're going to look at what happens when we have, when we want to calculate the concentration from KSP without the 1-to-1 ratio. So usually when it's a 1-to-1 ratio, we can make some assumptions. When it's not the 1-to-1 ratio, we can do a similar process to find the concentration. So calcium hydroxide breaks up into calcium ions and hydroxide ions. This is the solid, and these two both are aqueous. It is at equilibrium, and this is a solubility product problem. The next thing we can do is write our K equation. Okay. So our K equation is the products, which is the calcium times the hydroxide, and that is squared. Now, an important thing to note is the calcium concentration and the hydroxide concentrations will not be equal. They are not going to be equal. However, if the calcium hydroxide is X, the hydroxide concentration is going to be double that, or 2X. Now, the solubility of calcium hydroxide, to get 1 mole of calcium, you would need 1 mole of calcium hydroxide. If you need X moles of calcium, you would need X moles of calcium hydroxide being dissolved. So the ratio is a 1-to-2 ratio in this case. To solve a problem like this, you have to make only one assumption, and that is that calcium is going to be my X and hydroxide is going to be my 2X. So the next thing we do is we plug in the values. So we plug in the KSP, which is 1.3 times 10 to the negative 6th. The calcium, we're going to plug in X for it, and the hydroxide, we're going to plug in 2X for the hydroxide, but we have to remember that it is still squared because of the KSP equation, the equilibrium equation. So now, the next part is to solve for X. So to do that, we take 2X squared, which is 2X, times 2X, and multiply it by X. This equals 4X cubed, which equals our 1.3 times 10 to the negative 6th. To get X by itself, we need to take 1.3 times 10 to the negative 6, divide it by 4, and then that gives us x to the cube. To get x by itself, we have to take the cube root of the 1.3 times 10 to the negative 6 over 4, and we've got to take the cube root of that entire thing. This will give us the calcium concentration. To find the hydroxide concentration, we just need to multiply this by 2, and we will have the concentration of the calcium ions and the concentration of the hydroxide ions. So the next step is to use our calculator, and we type in 1.3 EE negative 6 divided by 4, and that equals a value, x equals a cube root of 3.25 times 10 to the negative 7th. We want the cube root of this, so on your calculator you're going to want to find either this button here or put parentheses around it and do a caret to the 1/3 power. So we calculate the cube root of this number, and our calcium concentration is equal to x, which happens to be in this case 6.88 times 10 to the 3rd molarity. We multiply that by 2 to get to the hydroxide, times 2, and this gives us a concentration value of 1.38 times 10 to the negative 2nd molarity for the hydroxide ions. This is how to solve a KSP problem when we're looking for concentration, when there is not a 1-to-1 ratio.